All right, so welcome to chemistry class, guys. Today, hopefully, you guys can see me. If you do see me, go ahead and put a thumbs up on your Zoom so that I know that I can see you guys. Those of you who are coming in, if you can hear me, put a thumbs up so I can see you. But, all right, good. We have more people come on the channel here. Excellent. All right, great. Starting a little late today, it looks like, but that's all right. Hopefully, you guys can catch up here. Hopefully, you guys did your homework. Actually, we didn't have any homework last night, so what we're just going to do is go over the pages that we needed to get done yesterday. So for our problems that we have here, number one, it says write down 2 interesting things you did over spring break. I had a lot of people give me some information on all my classes. I really appreciated you guys getting your input on that. I wanted to know what was going on with your guys' lives, so hopefully it was beneficial to you. Not only that, I want to hear if any of you guys would like to share what you guys did over the spring break. So if you would like to say something, I can unmute you real quick. I might need you guys to like raise your hand or say hey or anything like that. Anyone at all? No one at all? All right, that's okay. Well, we'll still continue for today then. So the idea here is we need to go through our concepts here on the worksheet that we have. So number 3, it says, is a sour taste a characteristic of an acid or a base? That would be an acid. What color does litmus turn in an acid? That would be red. What kind of ion does the acid produce in solution? That would be H positive. What kind of ion does a base produce? That would be OH negative. Name the acid HBr, hydrobromic acid. What term refers to the acids that can lose 2 or more protons in solution? Polyprotic. The blank concept of acids and bases applies only in aqueous solutions. That would be Arrhenius. And then finally, we had number 10 for our chemical reaction below. Establish the Brownstein-Lowry acid as well as the base and its conjugate base pairs. So coming from the left from HCl, it's going to be acid plus a base equals or is in equilibrium with a base conjugate as well as a conjugate acid as well. So there you go. That is what you guys needed to have done. I did look through ThinkWave, and it looked like some of you guys, unfortunately, sent me stuff that wasn't. I couldn't actually upload. For some reason, you guys added like pages or something to it. Like instead of putting it in a document format, you guys actually put it like our worksheet, but then pages. So I actually can't bring up pages on my computer. So I think only the people who were struggling with that, I think it was, let me bring up chemistry here real quick. I think it was only Jessica as well. Oh, in third order, actually fourth order, was Jessica and Anaya. So let me see here. Let me get to our 15.1 worksheet / homework. All right, so I did actually put on some of in the description or comments here. Make sure, yeah. So okay, so Jessica, first of all, yours I was unable to open your file, and Anaya was unable to open your file. And then some of you guys actually put in answers, and there was actually no answers at all. So I'm not really sure what the deal with that was. I think, I guess I can say it, Travis, you uploaded something, but I can't see any of the answers. So I don't know if you accidentally forgot to put the answers or what have you. But I don't have that. For Zach, I made a comment under yours as well, and that's pretty much it. All these answers all this entire worksheet is due by 3 o'clock today. So make sure you guys do get that in before 3 o'clock to receive credit. Remember that homework is worth 60% of your grade. If you didn't finish it yesterday, it is homework, so make sure you guys turn that in. Darcy? Okay. Well, that is okay. You'll have to deal with the consequences. All right. Anyway, we need to continue here then. All right. So we have consequences, aren't there? Jessica? Yes. Yes, you need to resend it. I guess I should make that. Jessica and Anaya, you need to resend your guys' paper because either upload it in like a document format because I can't open pages. So whatever you saved it to, pages or something, I'm unable to open it. All right, excellent. So we'll need. All right, wonderful. So hopefully you guys are on ThinkWave at this time. Or not at this time, but you've gone to ThinkWave and you've downloaded the worksheet for today. We're going to be going through that with you guys. So kind of more concepts. Notice that we're not dealing with stress anymore when we have pressure on an equation or concentration increasing on one side of the equation or our chemical equation. But we're dealing mostly with acids and bases here. That's really important to understand going further now into our study here. So first of all, acids have the same, if you have an acid, I guess I should say, if you have this idea here. So if you look on page 252, you have a lot of acids right there. On table 15.5, you have really strong acids, and then you have really weak acids. Notice this, that not all acids are the same. They all vary. So therefore, if you hear the question that all acids have the same strength, that is not true. It's not true because all of them have different types of ionizations when they are on a in a certain reaction, I guess you could say. So all of them, that is not necessarily true what we're talking about here. However, something else good that is really good to understand is that if you have a strong acid, usually it will I guess essentially ionize completely. I think we might have talked about this. I think we actually was one of our last points that we were covering. Strong acids usually ionize completely because they're able to lose that hydrogen that's attached to it. Notice that weak acids only partially ionize in a solution with other compounds and molecules. So make sure you guys understand that. Number 3, it says, to what extent determines how acids and bases react? Well, it's their ionization. I don't really want to say their ionization energy, but most of the time when you're putting acids and bases together, they're going to ionize. And in a couple of days, actually, we're going to go through something interesting. When we put an acid and a base together, we're always going to get some type of molecule, and we're going to see that in a little bit here. Number 4, the stronger the acid, the weaker its conjugate base is. So how is that kind of true here? So let's think about this. Yesterday we had an equation dealing with HCl, hydrochloric acid. So here's our HCl right here. Notice that we have chlorine bonded to a hydrogen atom that we see here. Now, if we take the hydrogen out, so this is a very strong acid. If we remove the H, well, what's going to happen to this is that it's only going to go to chlorine. We already kind of know anytime we have an acid, we're always going to have a proton to it. Proton, meaning one hydrogen atom attached to it. So therefore, if we had hydrogen here, it'd be a strong acid since you remove the H. So therefore, the H is no longer with the chlorine. It's just going to be the elemental chlorine. It's not going to be as acidic because it has that H to it. So that's very important for us to consider. The stronger the base, the weaker its conjugate acid. That's the next answer that we have there. So the stronger the base, the weaker the conjugate acid is. So understand that we're pretty much dealing with the Bronsted-Lowry concept when we're dealing with our acids and bases. So make sure you guys kind of understand that. It's almost a little bit of a review almost, but I want to make sure that you guys actually understood that before we continue. If you look on your worksheet on number 7, identify the direction of equilibrium for the following equation. This is very important, especially going throughout the rest of this chapter, because we're going to be getting into pH for the pH scale, and we are going to need to know what is the acid, what is the base, and when it produces, what are some of the conjugate bases and acids that we in fact have. However, number 7, I actually have a mistake in it. So if you look on number 7, that chemical equation right there, we have H2PO4 negative. Now, if you look on the other side of the equation, notice it says H2PO4 negative. That's incorrect. You guys need to change that to the second H2PO4 to H3PO4, and obviously that is going to be positive. So make sure you guys understand that. If you make sure you go to ThinkWave, press on that document, open it up, and make sure you change. So the first H2PO4 negative stays the same. Don't touch it. However, we have plus NH4 positive. Over on the other side of the equation, we have H3PO4. That's what it's going to be. It's not going to be H2PO4. It's going to be It's going to be H3PO4. I'll fix that up there. So make sure you cross out the 2 and put a 3 on the product side of our equation. At the end of that equation, you're going to have NH3. Now we need to continue. First of all, if we're ever trying to decide where the equilibrium is in an equation, this is pretty much what all you guys need to know, which direction of the equilibrium. Notice that this equilibrium isn't dealing with stress. It's only dealing with acids and bases. Notice the difference between that. That's very important, so don't get confused, because that was even last quarter, I guess you can say. Okay, so it says here, identify the direction of equilibrium for the following reaction. Number 6 is going to be very key for us. It says this. I believe that your document says true or false for number 6, right? Can you start out with that? Okay, good. Because when I originally did this, I forgot to put true or false in it, so I had to correct it. So number 6, true or false? The direction of the equilibrium will always favor the side of the weaker acid and the weaker base. That is true. And that is how we're pretty much going to figure out which way this equilibrium is actually going to go. So this isn't going to be too difficult to understand. I know since we're doing all these Zoom classes, it's going to be really difficult for us to kind of go through a lot of practice problems here. So I'm making this really basic for you guys. So first of all, we need to notice where in the world is our strong acid first. So where is our acid? First of all, let's look on page 252. That chart is actually going to show us where our strong acid is. So go ahead and take a look at that. And if you find it, try to either raise your hand and tell me what is the strong acid of that chemical equation with number 7. Chloe, did you raise your hand? No? She did not. Okay. I need someone to find the strong acid in number 7 for our worksheet. I can't hear any of you. So, okay, there we go. We have a hand. Okay, Chloe, yes. There you go. H3PO4. Very good. Notice that she saw in the equation, she went to page 252 on table 15.5 and looked there. And if you go down, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 from the top of where we have our strong acids, right there, we're going to see H3PO4. Kind of interesting there. Notice what is on the other side of the equation. What is on the other side of that chart? What is it? Someone raise their hand. It's directly right across. Anyone at all? I need someone to raise their hand and tell me because I had everyone mute. Okay, Zach. Yes. What's that? Say that one more time. Yes, it's the base. Okay, notice something about this. Okay, so we have H3PO4 and then H2PO4. So let me ask you, what makes something an acid? What makes it an acid? This is very key, very important. Okay, Darcy? Okay, very good. So if we look at phosphoric acid and dihydrogen phosphate acid, of course, notice that we're going to have 3 hydrogen atoms bonded to the phosphorus and then 2. So notice the difference there. The more hydrogen atoms that we have, the more acidic the compound is going to be. Very important concept to understand that. All right, fantastic. So we finally established that H3PO4 is in fact our acid. So we need to find our base. So can someone help me who has not answered yet? Find our base for me, please. I've already found it in my book. Anyone at all? It's in our book on page 252, table 15.5. Yes, Darcy? NH3, very good. Notice what is on the opposite side of our equation. What is on the opposite side? NH4, very good. So notice something, NH3, so we have only 3 H's compared to 4 H's. So the one that's the less is going to obviously be our base. So make sure you label on NH3, that is your base. Now, from our Brownstein-Lowry's, we've already established that it has conjugate acids and conjugate bases as well. So let me ask you, where is our conjugate base and which one is our conjugate acid? No one's answering this one. All right, so let's just work through this then. All right, so we have, let's go with the phosphate right here. So we have our H3PO4, and then that's our acid. We've already established that. And then we finally have our, on the other side, it's obviously we're going to have opposites. So we're looking for our base. So obviously we can go to H2PO4. And since we have fewer hydrogen atoms bonded to that phosphate, then we're going to have a weak base. So that's actually going to be our weak base. H2PO4 negative is our weak base. So make sure you label that. Now we look at NH4, and we should already know that NH4, so H4, we have more H's on the left side, on our reactant side than our product side. So therefore, that's going to be our weak acid, since there is a difference. We have, when we have an acid, there's going to be a conjugate base with it. If we have a base, we're going to have our conjugate acid with it. So starting on number 7 from the left-hand side, we're going to have a weak base plus a weak acid. We have our equilibrium sign. We have our acid, and then finally our base. So make sure you guys understand that. Now, can someone read to me number 6? What does number 6 say? How about Jeremy? Okay, pretty simple. So what did the question ask us for? What did the question ask us for, Anaya? What did the question on number 7 ask us for? There we go. So how do we find the direction of equilibrium, Anaya? There you go. So someone tell me, number 7, Jessica, which side has the weak base and the weak acid, the products or the reactants? So on the weak, it's going to go to the weaker acid and the weaker base. So which side has the weaker acid and the weaker base? The product side is on our right side. The reactant side, that's very important to know. And you have found the issue to the problem. That's what it is. It's the equilibrium is going to favor the reactant side. Hopefully you kind of understand that. We do have our homework problem at the bottom for that. I do want to go through probably one more example, and that could be the rest. And that's what we could just do for the rest of the day here. I'll just quickly write one down here. How far I can go left here. There we go. All right, so if we have HC2H3O, then we have a plus H H2O. Here's our equilibrium sign. Hopefully I'm still in the shop here. Okay, so that's the time for our space here. H3O. We'll make that positive there. And then plus C2H3O2 negative. All right, first of all, we need to find what our acid is. Hopefully that fits in the page. Oh, it does. Perfect. All right, so let's find where our acid is. Can someone find the acid for us? Usually when we want to find the acid, we need to see which one has the most hydronium ions attached to it. So which one has the most protons attached to it? Chloe, I'm down to Jeremy now. Jeremy, would you like to answer that? Close. We're trying to find our stronger acid. So we need to find the one that is the strongest acid in this chemical equation right here. So which one is the strongest? I would look on table 15.5. It's right there. There you go. Perfect. H3O. There it is. So here is our very strong acid. So let's find our base. Obviously, of course, the acids and bases are pretty much going to be together. So that is where this base is going to be. So here's our base. And then we always have opposites in science, of course. So what's the opposite of an acid according to our Bronstein-Lowry's theory? What would that be? So if we look here, what's this one going to be? There you go. Weak base. We have our weak base. And then what's this one going to be? Weak acid. So let me ask you, Michaela, where will this equilibrium shift for this equation? I hope she listened. Okay, there you go. So which way will this equation favor? Okay, so go to number 6. Okay, read number 6 for me. All right, so which one? So the left side. There you go. So this one is going to shift left. Did anyone notice I spelled weak fast wrong? Okay. There you go. That's correct. All right. My spelling is catching up to me. All right. So that is pretty much it that we need to do for today. Your homework for tonight is the bottom of that page. We're pretty much going to do what we just did now. You need to figure out the direction of the equilibrium. Please, please, please include the acid, the base, the weak acid, and the weak base, because the weak base and the weak acid is going to tell you which direction the equilibrium will go. As of now, you guys can be dismissed. If you have questions, stay on the line. I would love to answer your questions. Yes, Jessica. Yes, I can check that right now. Health class. Yes, because I know you sent yours over pages. Did you resend it? Okay, I will check it out real quickly. Okay. It's slowly loading. All right, excellent. Yes, it has been sent. Perfect. Wonderful. So I have your chemistry one. Your chemistry one looks good. And then for your health one, let me check it out real quick here. Yes, so it looks like you still need to upload the Word documents for that. So whatever you did sending the chemistry one, it was all set. There you go. Sounds good? All right, excellent. Chloe, you have a question? Yep. Oh, she's out. Jeremy? I think you're on. Oh, yeah.